Well, hello everyone. Thank you so much for joining in for this another beautiful episode of Graphversation. Good morning, good afternoon, good evening, good night, based on the time zone that you're joining in. My name is Siddhant, and I'm super excited to bring the second episode of Graphversation, a monthly dose of inspiration and knowledge by graph experts on the conversations around graph technology. Well, today I have with me Joffin Joy, who is full stack developer at Tuna Labs Shiksha Lokam. Hi, Joffin. How are you doing?
I'm fine, Sid. Thank you.
Great. So, well, before we begin with the session and I'll introduce Joffin, let me just quickly introduce everyone to the Neo4j community. Well, Neo4j loves community. And I'm super excited to talk to you about what we have in store for you. Well, one second. Okay, for those of you who don't know about Neo4j, it's a Swedish-based company, Swedish company at heart, based out of US. We started in 2007. The interesting fact is that the idea of Neo4j or the property graph was conceived on a flight to Mumbai when our co-founder and CEO Emil Ephraim was traveling to IIT Mumbai for a research project, and then he thought about this idea about property graph model, and he laid the foundations back in 2007 for Neo4j. We started as an open source community edition, a free version for all, but then we created an open core model where we still are having an open source version, but we are also having a closed source enterprise edition. We launched Neo4j 5, the version 5, last year in November 2022. Well, that's not all. We are the pioneers in the graph database industry. We literally created the graph database category, and we are proud of the fact that we are leading in this category. Uh, these are the rankings from DB Engines that say that we are the top graph database lead graph database player in the market out there. These are some of the numbers on the stats that I'll leave it for you to check it out later on. Well, what I'm interested about is that how excited you are about this particular session, for which I am going to give you a Neo4j t-shirt and an ebook, right? Sounds exciting. Sounds awesome, right? But you have to do something for me, which is what? You have to make a Twitter post about how excited you are for the session. I'm super excited, so I'm going to tweet in some time. But you also can tweet and win this awesome Neo4j t-shirt and this ebook by tagging me, that's my Twitter handle, and Neo4j. But make sure you use the hashtag graphs are everywhere as a mandate. Like these three things are a mandate for me to get to know that yes, you have tagged me, you have tagged Neo4j, and you use the hashtag. And I'm going to send you a t-shirt to the most creative post after the session is over. All right, with this, let me bring Joffin back on stage. And yes, we have Joffin. And Joffin, I would love to know more about you. Um, just help
Sure,
us
sure,
introduce.
sure, Sid. Thank you once again. It just feels great to be here. And as for me, as you said, I'm Joffin Joy. I'm a full stack developer at Tuner Labs. I mostly work with JavaScript stack like Mern and a bit of Scala from time to time. And for the last 1.5 years, I've been working with one of our client Shishalokam, where I've been developing backend systems, doing system and architecture design, and building organizational knowledge over specialized patterns and technologies. So that's what I do day to day.
Great, great. Thanks, Joffin. So you mentioned Tuner Labs. You mentioned Shiksha Lopam. I'm a little confused. Are you working with Tuner Labs? Are you working with Shiksha Lopam? What's the partnership over here? How does it look like?
Okay, very good question, Siddhant. So basically, Tuna Labs is a Bangalore-based IT consultancy firm, and we partner with other companies in their digital journey, which includes, building high-quality, scalable solutions powered by cloud. And Shishalogam is one such client of Tuna Labs. And as for the Shishalogam itself, it's an NGO which is part of a trust run by Mr. S.D. Shiblal, co-founder and ex-CEO of Infosys. The goal of Shishalogam is to improve educational domain in India, and we believe it can be done by helping and improving those in education leadership roles. Hence the tagline, catalyzing education leadership. Technically, what we do is we build digital public goods, which are essentially open source technology solutions, which can be adopted by NGOs, governments, and anybody else who want to emulate us. And Tonal Labs is one of the first and key technological partners for Shishalogam, and it has been a long-standing relationship. So that's how the Shishalogam Tonal Labs tie-up comes in, and how I'm projecting myself as a Shishalogam guy.
Nice. This is interesting partnership. Good to know that. Thanks, Joffin, for letting me know about it.
Sure.
Well, for people out there who are listening to us, I'm sure there will be a lot of questions around what Joffin is going to present today. But just before that, the topic that Joffin is going to present, that's actually a project being developed during Skill-A-Thon. It was a hackathon launched sometime back, where Nandan Nilekani was one of the mentors and judge, if I'm not wrong.
Yeah, yeah, exactly. Yeah,
Right. So, tell us a bit more about the hackathon, the Skill-A-Thon. Who organized this? What are the categories? And just an FYI, Joffin won, and his team won in the
the
category
challenge
number
for
category
four.
number 4. That's a great achievement. Congratulations to you and your team.
Thank
Well,
you.
I would love to know more about this hackathon. Who organized this, and then like what were the categories, and which category did you choose particularly?
Sure. So, Skill-A-Thon 1.0 was a 3-day hackathon organized by EkStep Foundation. It's another organization which we have close ties with. We, collaborate with them over different projects. And the aim of this hackathon was to promote Beckn protocol and to stimulate technological innovations around it. And on behalf of Shishalokam, this was our team, the Order of Shishalokam Luminaries, comprising of Ram Kumar, Vishwanath, and Kiran.
Okay, sounds good. This is interesting. Well, this brings me to the next question. What
Yeah.
is Beckn protocol?
Yeah, so natural, right?
Yeah.
So yeah, Beckn protocol is a protocol which enables us to create open networks where independent consumer and producer platforms can interact with each other seamlessly. Now, what does that mean? Now, consider the scenario where you want to purchase something of Amazon. What all you got to do? Go to the App Store or the Play Store, download the app, create a user account, and make your search. Then you'll get the product listing from Amazon. But now let's consider the scenario where the product you are looking for isn't actually available on Amazon, but it is on eBay. Now you got to do everything all over again, right? Install the app, create another user account, make a search, and purchase. And the key thing here is on each app you're only getting products from their own catalog, and this is one of the effect that Beckn is trying to solve. I would like to stress on the word effect here. Since on Beckn network, consumer and producer platforms can be independent, your app you are using to search for the products can be a standalone app. It doesn't have to be part of the producer side. And it can talk to all the producer network platforms on the network. Meaning, if you make a search on a backend enabled app, you get product listing from all the producers platforms on the network. So that's what Beckn is. But at the same time, I would like to stress on the fact that it's not really about the convenience of just having less number of apps on your phone and the headaches associated with it. It goes much deeper than that. The focus is clearly on the open network. Now, as you can see here, this chaotic diagram shows what an open network look like. There are producer platforms and consumer platforms which are interacting with each other directly. This way, all the users get access. I mean, each user on any consumer platform get access to all the producer platforms, and all producer platform get access to all the users. So, think about this scenario where there is a new seller coming into this network. They are compliant with the backend protocol. They immediately get access to a large number of users with minimal acquisition effort because all the users are already there and they have access to that. This can greatly even the playing field and make the market accessible to small scale entities. Like even think about as small as a shopkeeper who might want to deliver their products. That's the power of backend and the massive interoperability networks it can generate. More than that, in addition to that, I would like to point out that this is the brainchild of the same key people who architected India Stack and the UPI, which created a massive revolution in digital payments in India and is soon to go global. So, a lot of credentials are there behind the backend.
Oh, nice. This is great. Well, we understood a bit about the Beckn protocol, but I'm still confused with the fact that Shiksha Locum is primarily an edtech organization working in the education tech. How does this Beckn protocol or this interoperability can be put into an edtech domain specifically?
Okay, sure. Let me explain. Now, one of the best things about backend protocol is that it isn't limited to the e-commerce domain. Now, the example that I gave you, it's about the e-commerce because it's a bit more popular than everything else. But it can be applied to various other domains. And when we do that, it has got its own name. I want to stress that there is one big protocol, and we are just naming it when we are applying into different domains. So, to answer your question, when it is applied to e-commerce, it is called ONDC, but ONDC meaning Open Network for Digital Commerce. But when it is applied to EdTech, it is called the DSEP, which is Decentralized Skilling and Education Protocol. And in EdTech, you can think of it in terms of a platform like Udemy, where you are looking for the courses. You only get the Udemy courses, right, in the normal course in the existing systems. But think about if the Udemy was part of this DSCP network, you would have access to a lot more courses from maybe Coursera, edX, and any other platforms. So that's how backend gets applied to edtech. Now, for the totality, I'll just go over the other two also. When it comes to the healthcare, it is DHP or decentralized health protocol, which enables something called as a unified health interface. That would be like having access to a large number of doctors or digital mid-scale resources, and even going as far as to enable seamless transfer of your health reports between hospitals. uh, Transportation, it is called mobility. You can think of one app to hail taxis from multiple companies like Ola, Uber, etc. Given if they are on the open network. Actually, even though grouped under ONDC, a mobility solution was recently piloted in Bangalore called Namayatri. I think it's quite popular nowadays, and already generated close to around $2 million for its auto drivers. Now a bit more on the DACP side, the Shishalogam. What we can do is, when talking about DACP and the edtech field, the DACP is envisioned as a window to the opportunities on internet. Using DACP, any person has got the opportunity to get the best of courses, mentoring, jobs, internships, scholarships, and grants. And a select number of companies are already contributing to the protocol in order to enable these tracks and scenarios, and Shishlogam is one of them. At Shishlogam, as you know, we at Shishlogam already has got some products which enables mentors and mentees to connect with each other over video sessions or live calls. So what we are doing is we are building DACP enabled implementations like reference implementation services that will allow us to bring our mentoring services into the DACP, that plugging in effect, and to contribute to the protocol itself. We take the protocol, backend protocol, we identify what are the shortcomings of this. There might be a scenario where, let's just say, we want to support mentees' ability to search for mentors from a particular city during this time. Now we identify whether this protocol allows it or not. And if it doesn't, we contribute to the protocol itself. And all of this project, all of this development and the protocol contributions, everything comes under Shishalogam Elevate project. So that's how, in totality, that's how backend get applied to the edtech, and how Shishalogam is involved in the process. There's a big hand in how the backend is developing under Shishalogam.
Oh, nice. This is great. I thought the backend was just restricted to e-commerce, but interestingly, that you're covering up the entire spectrum of things from edtech to e-commerce to mobility to healthcare, health tech. Everything is coming under one roof with just one protocol. This is amazing.
Yeah.
Thanks, Joffin. Now, before we delve deep into your particular project that you did during Skill-A-Thon, I would like to know more about graphs. Your journey with graphs, how you started your journey with graphs. I guess you're Neo4j certified as well.
Yeah.
What made you go for a certification? I have a lot of questions around graphs. We are doing a Graphversation, the conversation around graphs. So why not to talk about graphs? Like, what was your first love with graphs?
Sure, I think it's an interesting story as well. My first exposure to Graph database was when I was working on an open source code base that we actively contribute to at Shishalogam. So as I said, Shishalogam, everything we do is open sourced. Anybody can adopt whatever we are building, and at the same time we do contribute to other existing open source code bases. And there was this one particular code base that I was working on. It was a Scala code base, and it was using Neo4j. But there, I didn't get a chance to use the database directly though, since it was abstracted away into deeper layers or the platform code, as we say. But I was very curious about this new concept. I mean, that was the first time I came to know about the graph and the Neo4j in particular. So I basically went around watching and reading everything I can about Neo4j, and it just blew my mind. The way ideation works with Neo4j is so intuitive, and the data modeling is exactly like how we think about the problem and the solution. For example, let's just say we want to create a system where we have to record interactions between the users. Now, in traditional sense, you would have to create user tables and then interactions table, create joins, then hold references between them. But in Neo4j, it is as simple as creating a node for each user and simply creating a relationship between them. There is minimal translation required here, and it's such a natural way to ideate, when we are trying to find a solution to a problem. And that, really stood out for me. That was a game changer, and I was really impressed by it. And then I went around looking for more resources, and that's when I found Neo4j's Graph Academy. So there were like really well done courses there as well, using which I upskill myself on Neo4j, then got myself Neo4j certified. And and the best thing is all that knowledge just came together during the hackathon perfectly.
Oh, nice. Did you get your Graph Academy T-shirt as well, the Neo4j certified T-shirt as well?
Yes, it took a bit of while. It had to come from Latvia, I guess, and I was, like waiting, and the funny thing is, like, it took around 3 weeks, I guess, and I
Okay.
even messaged one of the like coordinator. Okay, where's my T-shirt? Can you see where it is? Can you give me a list? Like a tracking link and all. So I was, way too much invested in the whole certification process as well.
Oh, great. So, well, just for your knowledge and for others' knowledge, we have streamlined the process a lot. So, no longer the Graph Academy T-shirts are shipped from US or anywhere across the
Hmm.
globe. For people who get certified in India, it gets shipped directly from India, so it's a faster delivery. So you get it within what, less than 5 days. That's a good thing.
Wow, wow,
Uh,
yeah, yeah,
you don't have to wait
definitely.
for 3 weeks, and you can flaunt your T-shirts in the next 5 days the moment you get certified.
Exactly.
Yeah, and I'll talk more about Graph Academy towards the end. How you can get certified, like for people who are listening to us, how you can get certified on Neo4j. We have two interesting certifications. More to that towards the end. Well, with this, let's move on to your topic, the project that you did at Skill-A-Thon. I would love to know more about the project itself. What was the project all about? How did you use Neo4j and graphs in your project?
Sure. So before we delve into the project itself, there are a few things, technical things that we have to explain before. Otherwise, it won't make sense. So
Sure.
it's basically how the technicality of the Beckn is. And on the technical side, Beckn protocol requires three components to work. It's called the BAP, the Beckn Application Platform, which is the consumer platform. The earlier we were talking about consumer platform and the producer platform, right? So BAP would be the consumer platform where the user app would be talking to. Then there is the BPP or the Beckn Provider Platform. This is the producer platform. And then there is something called as a BG, or the Beckn Gateway, which has got something called as a registry. Again, Beckn registry. Registries where the information about all the BBPs are stored. So when a user makes a request or search from the BAP, that request goes to the BG, and BG looks into the registry and then takes all the addresses of the BPPs and broadcasts it to all the BPPs. And once BPPs get the information, the request for the search, it can process the search and then talk to the BAP directly, because that information about the BAP will be there in the request that is being passed on. So that's how it works in the backend technical side. And at Shishilagam, we have been building both BAP and BPP so that our mentoring platform is available on the DSEP network and is a digital public good to be adopted by anybody else. Now, Now, coming to the project itself, our project was called SLO Horizon, which is short for Shishalagam Open Horizon. This was an entry for Challenge 4 in Skill-A-Thon. There were like four challenges in total. The challenge one was about enabling consumers, meaning building BAPs, and challenge two was about enabling producers, meaning the BPPs. And then challenge three was about the trust element on the Beckn network through verifiable credentials. I mean, given that the users and producers are not on the same platform, we need additional mechanisms to ensure that everybody is who they are claiming to be, right? Because it's decentralized. So that was challenge three. As for the challenge four, it was about the innovation by bringing in advanced technologies like AI, machine learning, chat GPT, etc. And that's what we focused on, in our project by building a recommendation engine. A bit more about that. What we did is, as a team, we identified discovery as one of the most important aspect in an open network. This was because, unlike other platforms where users and sessions are in the same place, in DSCP, discovery is purely done through user search. As such, the quality of the discovery of the sessions depend a lot on the quality of those searches. So this could lead to a scenario like a user searching for a session with a suboptimal search term or a filter, and the BPP is not identifying what the user is trying to find, even though it might have had the best sessions for that particular user. And there would be no way for the BAP to identify this is happening because the collective session data is not with the BAP; it's always with the BPP. And that's where our recommendation engine comes in. Recommendation engine will make use of the session it has already seen and user actions around it, and then make intelligent suggestions to the users without explicit searches. The user doesn't have to search for things to make sure that he or she is getting the best suggestions. And these were our primary goals, to implement Neo4j Graph database and build a recommendation engine which uses both collaborative and content filtering, and then develop a smart auto search feature on top of it. Now, to answer your question, why we went with the graph, like why the affinity for the graphs in this particular thing. When I was doing the certification, as I said, I was reading a bit about it, and uh, in Neo4j, their website, they had like three case studies about recommendation engines being deployed in like massive scale. One of them was at like ATPCO for airline bookings and all. So I kind of knew that okay, Neo4j can be applied for this recommendation engine, and that's why we went with the recommendation engine. But at the end of the day, like it was a collective team choice, and we thought it would be an innovative thing to do because graph databases are exotic, right? So that was our
Great,
thing.
great. I will also like to know, like, while you're building on this project on graph databases um using Neo4j, what kind of a support mechanism that you got from Neo4j? This in particular, I'm curious to know whether we did our job well, or whether the community really helped you out or not. So this is particularly for us as a feedback to learn whether we are doing it well, or what things that you feel that we should work on it.
Okay, regarding that, there is a very funny story as well. So, what actually happened is that during the hackathon, there was an idea submission phase where we had to first submit our idea and then wait for the confirmation from the EkStep Foundation before we start with the development. And the days between initial idea submission and the project submission, there were only like 5 days. And when we
Okay.
were talking and when we were making submission, I mean the idea submission, we really didn't have any idea about how to implement a recommendation engine or the algorithms which are required, or even how the Neo4j GDS works, etc. I mean, I'm a Neo4j certified professional, but I have never used GDS before. Even my certification was not on the graphs, data science side, so it was a completely new thing. And that means, when we were submitting our idea, it was basically just a punt. We had no idea if we will be able to complete it in time or not. So, immediately after we submitted our idea, what I did is I basically went around messaging Neo4j employees asking for targeted resources to upskill on. We only have 5 days, 2 days before we get the confirmation that we are there or not, and then 2-3 days to implement it. So many of them, not many of them, some of them responded by saying that they don't have anything targeted for the use case. So I told them, okay, like, I am part of this hackathon, and this is something that I'm going to implement. I'll be generating the synthetic data, so I don't have the, I can't use supervised learning and all, because there's no labeling, etc. And most of them said they don't have anything targeted towards it. But then there was like Ajil Vedan, who is a Neo4j employee, he's a solution architect. And he replied with a bunch of blogs, YouTube video links, and then most importantly recommended Estelle C4's book on GDS. So Estelle C4 is a author of a book on GDS, Neo4j GDS, which talks about the different algorithms that can be used, etc. So naturally, I went around looking for the book and found the book to be like quite bulky. It had around 300 pages long. So that was not going to work. I mean, it's not targeted enough for us. 5 days, 300 pages, no way. So then I got the idea, maybe what if I can find Estelle itself? Maybe she can help me with narrowing down the topics. And that's exactly what happened. I found her in one of the social media platforms. She was very kind enough to give targeted resources, even more targeted resources on with more implementation details, and even help me narrow down the concept to a very smaller list. So the process of elimination of the things that won't work, that happened very quickly because of the help from Estelle and Agil. And Estelle even went as far as to validate my arguments for the quality of the collaborative filtering. I mean, that's one of the technique that we implemented. So I made a like a argument about how we can contest that. Okay, our recommendations are of good quality. So Estelle was kind enough to even validate that. And given that how touch and go was our final submission, like we only had like 5 hours before we had to like submit our project, and we still had to do like a documentation, deployment, testing, video demo, etc. And if it wasn't for their help, we would have been completely lost. The rush of this was just amazing. Everybody was just pushing to the absolute limit, and the help from them really made the difference. So community.
Great, awesome. So we're doing a good job. Great, good to know that. Well, yes, there are a lot of other community resources as well for people who want to upskill themselves on Neo4j. The book which Joffin is referring to is this by Estella. This is definitely considered as the holy Bible if you want to get into graph data science and know more about using graph data science with Neo4j. The one which I'm giving away is this graph data processing with Cypher by Ravindranath Antapu. This is another amazing book if you want to get started with Neo4j and want to know more about our Cypher, our query language, our graph query language, what it is, how does it work, various clauses, blah, 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 and stuff. Cool. This brings me to the interesting part, which is the graph data science. I know graph data science, definitely what graph data science is, but I'm sure people who are listening to us might not know what graph data science is, what Neo4j has to offer for the machine learning or for the data scientists out there. Would you like to take a minute and talk about what Neo4j graph data science is all about? Also, help us understand a bit more into depth your architecture, your working of your project, and how you use graph data science specifically in your project.
Sure. So, Graph Data Science is a plugin. I mean, there's a GDS, it's called the GDS plugin, which is developed by the Neo4j. The basic idea is these are two different entities. Like there's the Neo4j graph where we are storing the data, and then there is the optional GDS library. And what it does is, it becomes very apparent when we are going through the architecture and the working. But what it does is it takes, very complicated topics like machine learning, KNN algorithms, graph projections, and all those kind of things, and makes it easy for us to use it in our graph database. So it is a like a what do we say, amalgamation of both the graph database and the algorithms that can run on those the database. So what actually happens is, you don't, like, even if you don't know too much about how one particular machine learning algorithm works, you just have to, fine tune the thing with the GDS function. So you can say, okay, uh, run this algorithm this number of times, and use this graph for it. So with that, it becomes very easy for us to develop things. And without the GDS, we wouldn't have been able to do our project. I mean, machine learning, if we had to, develop our own machine learning algorithms, implement them, test it, and all those kind of things, it's not going to happen. So GDS, really adds to the powerhouse which graph database is, and they are so seamless in between. So that's about the GDS. I hope that was like explanative enough. Anyway, when we are going through the actual working of our algorithms, we can see how GDS was used.
Great. I'm looking forward to it.
Okay. So coming back to the project, this was our architecture, the OSL plus recommendation architecture. As you can see, we have the BAP and the BPP, and the BPP is actually talking to our interface with our mentoring services. Mentoring services, as I said, it's a different product from our side, which enables the mentors and the mentees to interact with each other. So by building a BAP and a BPP, what we are doing is we are bringing these mentoring services into the network, and at the same time, anybody can, everything is open sourced, including this hackathon project is open sourced. So you can take whatever want and then implement it, fork it, develop it further. And even if you are an organization and serious about, being in this sphere, we can even collaborate as well. So, and yes, at the same time, you can see the recommendation engine here, which is leveraging the Neo4j. So this was our architecture: the BAP, which talks to the BPP through BG or directly, then the BPP, which talks to the mentoring, and the recommendation engine, which plugs into the BAP, leveraging the Neo4j. And then there is an app called Sunbird app, where everything was, like integrated. As for that integration, we implemented our DSEP workflows in the app I said, the Sunbird app. It's an app we contribute to from Shishalogam, once again, open source project. And the app enables something we call as improvement projects, whereby educational leaders can identify which is the area that they need to improve, and then get tailor-made improvement projects to make that improvement. So for example, let's just say there is a principal in a school, and he wants to improve his school's infrastructure. Using Sunbird app, he can identify the current state of the infrastructure through data collection, set targets for the improvement, find suitable improvement projects, and keep a track of that journey. Now, the only difference is, as of right now, it didn't have a option to seek mentorship during that process, during that journey. But by bringing the DSCP workflows, now it is enabled. So now education leaders can get targeted mentors, mentoring from domain expert on Sunbird app. So that was the integration part. Now, as for the, like working, since this was a hackathon, we really didn't have the real world data to play around with. So we generated our own data, and the logic, the reasoning behind the scripts and all, it will become apparent when we are going through the algorithms. So the logic was, on the BPP side, we generated around 300 sessions, which was split into 15 clusters. So each cluster had around 20 sessions each, and each session is identified as session title, with a session title of the format, session title and a cluster number. So for example, as you can see here, designing effective school facilities, cluster number 10, which denotes that this particular session belongs to cluster 10. And then we went over to the BAP side, ran another script, and which fetched the first 200 sessions, meaning the first 10 clusters. And for each cluster, we generated around 15 users. And for each user, we selected 7 random, sessions from the same cluster that it is part of, and made them enroll into it, and then rated the sessions. So once that is done, this is the graph that we get. And you can see right away in the graph that the clustering of the users and the items or the sessions are already very apparent in the graph, right? You can see 1, 2, 3, 4, 5, up to 10 clusters. So this graph is being taken from the Neo4j browser itself. Now, it's not really wise to run this many nodes, show this many nodes in the Neo4j browser directly. The Chrome will be just screaming at you. So I have just put it in the slide itself. As you can see, there are 200 item nodes, which are sessions, and there are around 150 user nodes, who enrolled into 200 sessions and rated them. Now, this is a graph model. This is the graph model, which is an abstraction of the graph that we have, which basically says, what are the graphs there and what are the labels for the nodes and how they are interacting with each other through the nodes, etc., relationships, etc. In this particular context, for our recommendation engine and all, we can simply ignore the mentor, provider, and category nodes and their relationships, as they are not really part of the recommendation process. Other than that, as I said, item nodes equates to the session, and the rated relationship, as you can see here, between the item and the user relationship implies that the user enrolled into that particular session and rated it between 1 to 5. We can also see that there is a topic nodes, which are linked to the item nodes itself, the session nodes itself, through a relationship called is about. And there the topic nodes are generated by extracting nouns and verbs from the session title. We can have a look at one such session in Neo4j browser as well. So once again, like this is the part that we are concerned about: the item, user, and the topic. Now we can just have a look at the Neo4j browser. First of all, I'll just remove all the relationship which we don't care about at this point. No, we didn't have any. And we can see a node, particular session. And you can see that this is a session that we are interested in, that we fetched right now. And the title is Creating Effective Learning Spaces for English Language Learners. And it is from cluster 2. Now, if you see here, you can see a number of, around 6 topics which are extracted from the title. So each learners, learning, languages, teach each English, spaces, etc. At the same time, you can see the users as well, user nodes who rated the session. And the rating value is stored in the rated relationship itself. So if you're clicking on the rated, we can see that there is a number here, rated, rated. It's a random number. So it will be between 1 to 5. And now if we want to see one cluster full, we can see that as well, just for the completedness. So this is the cluster 2, and you can see 15 users, 20 items, and 44 topics which were extracted from the session title. Now the thing is, these topics might not be strictly from this particular cluster. There might be other clusters having these topics associated with them, but that's about it. So that was
Uh,
the part where we were, like engineering the data that we needed to, run the algorithms.
Great. And since you're talking about graph data science, did you see any significant difference when you used graph data science in your project? Like, was there any performance changes, or like what was your experience when you used graph data science?
Oh, the given the time crunch that we had and how, like accessible the GDS is, we didn't even think about anything else right now. When we were doing our implementations, like that was the only way for us to go, and that would be, like we just didn't even care about the performance of it. So I can't really comment about that part right now.
Okay, cool. That should be fine. But I really loved the part where you were showing the entire clusters that were
Yeah.
there, the entire graph clusters that were there. Like, to be honest, in a hackathon, doing something like this, it's a massive, massive effort. So great job to you and your team on doing something during a hackathon and winning the hackathon as well. So great job. Well, moving on next, would you like to talk more about the collaborative filtering part? How does the filtering happens in the application?
Sure, sure. So now the first, that was the first technique that we implemented. So it is a collaborative filtering is a technique by which we can, like do recommendations. Now the idea here is that we don't consider the content of the session at all. So whatever the title of the session is or whatever, we don't really care about it or any associated topics or nothing. Recommendation is purely based on user to user similarity. Meaning, consider it like this: say there is a group of users enrolled into a common set of sessions. We can infer that those users might have common interests by their choices because they enrolled into a common set of sessions, right? And hence consider them as similar users. In that case, we can also make an argument that since they are similar users, they might be interested in sessions which were enrolled in by each other. So that's collaborative filtering. So basically, when we are dumping it down, we can say recommending sessions which were enrolled in by users similar to you. And as for the working, this is the process that we had to undertake. I mean, there are different ways by which we can do collaborative filtering, but in our implementation, these were the steps that we adopted. Now there are four steps involved here. The first one is the graph projection, as you can see here, which is a process of extracting a subgraph from the original big graph. The earlier you saw the big graph, right? But by using graph projection functions, what we can do is we can take a subset of graph with only nodes and relationships that are relevant to our algorithms, further algorithms, and then put it into the memory, I mean the RAM, so that it's more efficient. And in this particular case, we only needed item and user nodes because, as I said, we don't really care about the topics or the session titles or anything like that. It's just the item nodes and the user nodes, along with the relationship that connects them, rated relationship, which was the rated relationship. So a graph projection can be generated as a, using a GDS function called GDS graph dot projection. And once we have the projection, we can run an embedding algorithm called FastRP or fast random projection, which what this basically does is it converts each node into a set of numbers while somehow retaining the characteristics of the node. I mean the relationship between different nodes and all that is expressed as a set of numbers. Now, the logic here is that even though these numbers might not make much sense to us, as you can see here, this number doesn't say anything about that node to us as humans. It's the ideal data structure for running machine learning algorithms. And in the next step, that is what we need to use. So once we have the embedding, after the first two process, we have the embedding. We run a very popular machine learning algorithm called K nearest neighbors, which will compute the similarities between each pair of nodes in the projection that we chose, and the relationship, the similarity between each node and its K nearest neighbors. So K can be a number that we can change, and we write the similarity back into a graph as a new relationship between those nodes. So we in our project we called it the collapse similar because we had something else, content similar as well. So we said collapse similar between the nodes with a property called score. So the score will keep track of what is the similarity between two nodes, and we can actually see this in the Neo4j graph itself. So one second. Oh, I haven't run the collaborative filtering. So I have not run the algorithm yet. So I'll just run it. So what I have done is I have exposed it as a, what do we say, like API. So I can simply run it from Postman. So we'll just run it. Now the computation of the collaborative filtering is done. Then we can go back, sorry, and run the algorithm again. And this time we are getting the nodes. So item nodes and the user node and the relationship between them. So as you can see here, we created new relationships between them, collapse similar, and it is holding the value something called as a score, which is a measure of the similarity between them. Now you can set a cutoff score and or like if it is below some value, do not write this relationship, and also it's not going to write to every pair of nodes in the graph, but this is how it looks like. Coming back, this is the graph we will get once again after running the collaborative filtering. I have marked the collaborative filter, like collapse similar relationships as green, and you can see that now the clustering becomes even more apparent than earlier because those relationships are bringing those clusters together. So this is the graph that it will look like. On the app side, what we did is this was implemented in the home screen as a recommendation, recommendation session, recommended sessions based on users similar to you. And if you see here, you can see that all the sessions being suggested here are coming from the same cluster, cluster number 3. That is because the user who is logged in right now is belonging to that particular session. So now one of the most important advantage of collaborative filtering is that since it doesn't really care about the context of the data or the session, it can recommend sessions which are widely different from what the user is used to. So like a unknown session which are relevant to that particular user, even though they might never search for it. That's why, like we were very keen on implementing collaborative filtering in our app, so that the recommendation process is as exotic as possible. Now, I can't close off this section without telling you one of the most important, limitation with collaborative filtering. Now, since collaborative filtering is based on the user-to-user similarities and their interactions with sessions, it is impossible to recommend a session which hasn't had at least one user already enrolled into it. So let's just say a new session is coming to the BAP, we will never be able to, recommend that. As you can see here, this is a cluster number 2, and there is a new node here. We will never be able to recommend this one. So that's a major drawback with collaborative filtering.
And to overcome this collaborative filtering, what's the next solution to it?
To overcome that, we have to do something called as a content base. That's why we were keen on doing both for our recommendation engine.
Okay.
So content based filtering works. It's a much simpler, in our particular case, it's a much simpler process, and the similarity is computed based only on the attributes of the session. So here the only attribute is the session title, which from which we extracted the topics. So we are only considering the topics here. So we can say if two sessions have common topics between them, they are more likely to be similar to each other than the ones with less number of topics, common topics. Now, I really want to stress that content based similarity doesn't really have to be about common nodes. It can also be about similarity between the properties within the item node. So, if an session has got the session title, timing, the location, etc., that all can be part of it. Doesn't have to be like about a node, external node. But for us, since the only characteristic that was unique for each session was the title, we went with the topics, and our choice of algorithm also reflect that choice. And since the similarity is based on the content and not based on the user interaction, this is the key point here. There is no call start problem here. The earlier problem that I said, were we not being able to recommend the sessions which had not had any user interaction, it's called the call start problem. uh, that issue is no longer a problem here, because any new node which is coming to any new session which is coming to the node, we can simply run this algorithm, find similar nodes, and when we are doing recommendations, we can take one of these and show it to the user. As for the process regarding around it, the first step is same as the collaborative filtering. We have to create a projection, but this time we include only items and the topic nodes along with the ease about relationship. We don't, as I said, we don't care about the user interaction part, right? So we don't need those relationships and the nodes, and because those are the only relevant elements from the graph. And then we run the GDS algorithm called node similarity algorithm, which is again a ready-made algorithm which is made available through GDS, which internally uses an algorithm called Jacquard algorithm. What Jacquard algorithm does is it takes each pair of items or the session nodes and take into ratio of number of common topics between them and the number of all the topics related to both of them. So like common nodes, number of common nodes divide by all the topics related to them. We can see that in action as well. I will first delete the collaborative filtering so it's not that messy, and then run the content based algorithm. We have run it, going back, and now we can choose one pair of items with the lowest rating, lowest similarity score. So the content similarity, and you can see that again content similar, and we have the score value 0. 0.4, which is the lowest possible, because I had set a cutoff value. If it's below 4, 0. 0.4, do not write this content. Don't make this recommendation link between the nodes. And now in order to see why this is zero point 0.4, what we can do is we can simply see the neighboring nodes to it. Zoom out, And if we see here, we have two nodes which are common to both. Two nodes, but there are around five total nodes because two of them belongs to the left side item, and on the right side we have one more extra. So 2 divided by 5, we get 0. 0.5, and that's how we calculate the algorithm. Sorry, the recommendation value using this algorithm. And we can even look at the code as well.
Yeah.
So I kind of missed about the, when we were talking about the collaborative part, but let's see, we can look into it as for the content based one. So this is the GDS function call to generate the projection. As you can see here, the projection, I'm naming it content graph because we are using it for the content collaborative, algorithms. Sorry, content based algorithms. And we are choosing the item and the topic nodes. Item is a session node, and the relationship between them is about. So this particular content graph projection doesn't have any other nodes and the relationship. And then we are running the node similarity algorithm, which is again from GDS. And we are writing the similarity between each node using the relationship content similar and similarity cutoff. I'm saying, okay, zero point 0.4. If it's below zero point 0.4, do not write that. And we are saying, okay, it should be computed between item and topic nodes. So this is how, node similarity algorithm works. And as for the, again, once again, coming back to the graph, we can see that we have added the content similar edges as well. Now we can see that these similar, content similar relationships are going between the clusters, while
Mm.
the collaborative filtering is, still confined to each cluster. So
Cluster.
that's the entire logic, being able to recommend sessions which are, not part of any cluster, purely based on the relationship between, similarity between the sessions. And on the Sunbird side, this is what we did. So when you are opening a particular session and you are watching the, viewing the session details, at the bottom you can see the related sessions. So here we are saying we are viewing a session called innovative approaches to teaching history, and all the recommendations are innovative approaches to teaching something, and they are all coming from different clusters. So that's the power of, a content based filtering.
Great. This is awesome. Well, I'm also curious to know, like, since the hackathon is already over, what's the future scope of this particular project? Like, how you're taking this project forward?
Now, one other thing, what we did, since this was a hackathon project, there were, like some choices that we made, which might not be, the most optimal. For example, let's just say we blindly extracted the nouns and verbs from the session title, right? And when we are considering that, there might be topics which shouldn't be really considered as a topic in itself, like just to say building. That is one of the topic which should be extracted since it's a noun. Sorry, it's a verb, it's a building process, right? So that might not be the way to go about it in, in a broader, like in a production quality system. We might have to do some semantic analysis, or even bring in AI to, find other keywords related to this. So that's the future scope of our project, where we want to fine tune each of these things. Right now we have the, framework for everything. We just need to take each of the step that we did, understand where we can make more value, and then fine tune it. So that's a future scope that we are aiming for.
Got it. Interesting. Well, we are almost towards the end of our conversation around graphs today. Thank you so much, Joffin, for giving us your insight about the project that you did during Skill-A-Thon. It was lovely talking to you. Do you have any last thoughts, any last comments before I jump on to uh, the the other resources which the people listening to us can refer to?
Sure. So first of all, thank you for having me over, and this experience has been just wonderful, especially talking to you. This interaction, it's the first time I'm doing this something like this, so it's, extra special for me. And as for the viewers that we are having, I would say everybody should explore the graph databases and the Neo4j in particular, maybe because there is a great deal of value to be found there. It's a like different, something different from the traditional databases that we are more used to, and it's a different ideation phase as well. So as somebody like who did a hackathon, we only had like 5 days. There were like a lot of data science concept to be learned, and the machine learning algorithms and all this yada yada going around. Being able to do that in just 5 days, that's a power of graph databases and the supporting structure around it. So I guess if you are somebody who really wants to improve yourself, you should really check out the graph databases and Neo4j. That's my like final word.
Awesome. This is great. Thank you so much. Uh, Great work again, Joffin, you and your team on building this amazing project during Skill-A-Thon. I love the interaction that we had today. The second episode was really special. And I'm looking forward to the third episode now, which I'm going to announce in some time. When is it? But let me just quickly talk about the community. Um, okay, I am hoping that you're tweeting for winning an awesome t-shirt, Neo4j t-shirt and an ebook. But we have some amazing resources for you as well. Just a second. Okay. So, well, you can continue your graph journey with Graph Academy just the way Joffin did Graph Academy courses, got himself certified. We have these two amazing certifications that you can check out. One is Neo4j Graph Data Science certification. Another one is Neo4j Certified Profession. Both are amazing certifications. And the moment you do either of them, you get a t-shirt shipped to your doorstep. If you do both, you get two t-shirts shipped to your doorstep. Quite exciting. Well, I have just prompted the link for Graph Academy on the screen. Do take a note of it. It's graphacademy.neo4j.com and complete your certifications ASAP. Coming on next is if you want to speak at our meetups, would you like to come to speak at a Graphversation or do an online session? We do a lot of them online, offline. We have a lot of community meetups that happen within India, within APAC, across the globe. You can of course submit your talks to us. That's the link that you can use. It's dev.neo4j.com/submit hyphen yours hyphen talk. So submit your talks to us, and we will. So it's a rolling form. There's no deadline, and we'll keep reviewing your applications, and we'll contact you once we are doing the next session. All right. Next is to talk about the Ninja program. It's a very exclusive program for people who are expert around graphs, who are actively contributing to the graph ecosystem, giving back to the ecosystem by sharing the knowledge around graphs and graph databases and Neo4j. We have this amazing program. If you wish to join this program, if you feel that you are an expert in graphs, uh, do check out this link bit.ly/neo4j ninjas. It's a case sensitive link, so make sure of capital N's which are out there in the link. And the next one is the Notes 2022. This was something which happened last year, where we had a virtual marathon for 24 hours, starting from Americas, ending in EMEA, if I'm not wrong, where 24 hours we brought in graph content from beginner, intermediate, advanced, amazing speakers who are talking to us from across the globe around graph databases and Neo4j. If you want to check out the replay, if you want to see the playlist, we have categorized them as beginner, intermediate, advanced based on the level that you are in. You can follow the link that I've just shared on the screen. There are other playlists as well, a YouTube playlist that you can check out some from that particular playlist, from that particular notes sessions. We are also coming up with Notes 2023 in some time. The dates and the CFP will be announced soon. So make sure you check us out on social media, on Twitter, on LinkedIn, on community platforms to stay updated about the Note 2023 CFP and registrations. Well, last but not the least is about our Discord channel and our community forum. So we have our Discord channel, and you can join the Discord channel via dev.neo4j.com/chat. Stay connected with other developers out there. It's a vibrant community of developers talking to each other, answering queries, asking questions, helping each other out. A very amazing community. Or you can go to this discourse forum where you can post in your questions and get responded by the Neo4j experts and people out in the community quickly in short span of time. The URL is dev.neo4j.com/community. All right, so this brings me towards the end of our session, this second episode of Graphversation. But before we sign off the Graphversation episode 2, I'm going to talk about Graphversation episode 3, which is happening next month on May 11th from 10 to 11 a.m. IST. Let me just make an edit on the timing. Sorry, my bad. And we're doing this third episode with Neha Setia, who is a developer advocate at Site. And she's having another interesting topic, another recommendation topic. And she's going to talk about next level personalization, how web scraping and graph databases power recommendation engines. I'm looking forward to the episode 3, but before that, thank you so much, Joffin, once again for coming for our second episode and enlightening us with your thoughts around graphs and graph databases, this amazing world of graphs. I'm super excited to see how the industry pans out. There's so much love that's coming into us on YouTube, on LinkedIn, on Facebook, on Twitter when we went live. Do check that out and have a great time ahead. Have a good day ahead.
Same to you, Sid. Thank you so much. Have a
Thank you.
nice day.
Thanks so much. Signing it off. Bye. Take care.
Okay, bye bye.